All right, you lazy chemistry bums. We are going to spend some time introducing the next topic here, and that next topic, of course, is going to be reactions. All right, so here's the things you should already be able to do. So if you're on par, ready to move on, okay, you should be able to write skeleton equations with the correct formulas. You should be able to predict the products of a potential reaction based on the reaction types we've talked about, so combustion versus decomposition versus combination synthesis, single, double replacement, all right? And you should also be able to recognize the symbols. You guys do have the old reference sheet. Now, the symbols, like the AQ, solid, gas, that's going to be a little more important to us later, but still, just for good measure, make sure you're acquainting yourself with those symbols. They're not throwing you off when you see them, okay? So, if you're not confident with this stuff right here, you need to spend some time getting confident with this stuff, because we're just going to keep adding layer and layer to what we're doing, okay? So that might mean spending some time with me. It might mean getting some tutorial time in, going back, watching lectures, going to Whitman sessions, but get confident with this stuff ASAP, all right? But let's move forward. So, balancing reactions. Now, I know many of you know what this means because you've done it in your previous science classes. Of course, we're going to take it to the next level, but some of this information should not be new to you guys, some of you at least. All right, so we have the whole conservation of matter issue to deal with, right? We cannot create matter, nor can we just get rid of matter. So in our chemical equations, we need to account for where all the atoms came from and where they all go. Okay, so not just the materials, but also the amounts of those materials need to be accounted for. And I'm going to show you what that looks like. The first thing we have to do, though, is differentiate between subscripts and coefficients and how they're used and what they mean. All right, so subscripts are used to write the correct formulas. Right, so that's what we learned last semester. Right, so if I say to write the formula for aluminum chloride, you know to write AlCl3, and that little 3 is your subscript. In water, the H2O2 is your subscript. Okay? So when I say subscript, those are the numbers I'm talking about. Coefficients are other numbers we add to balance a chemical reaction, right? So, and the reason we have to use coefficients is we can't just arbitrarily change our formulas. We have to write the formula in the correct way to balance out our charges for ionic compounds, etc. Okay, and then if we need to balance, the amounts aren't correct on both sides, we use a coefficient, which is a number that we write before our formula. Okay, and I'll show you guys what that looks like. And I know many of you have already used coefficients and subscripts before, but I'm just going to reiterate some really, really important principles here. Okay, so make sure you can differentiate between subscripts and coefficients. Subscript is a little number as part of our formula. The coefficient are numbers we write after our formulas are written if we need to balance. Okay? So let's talk about what balancing an equation actually looks like in practice. All right? So how do you know if an equation needs to be balanced? Right? That's an important question. What would you look for? Okay? So if I have you write out a chemical reaction, right? The first thing you're going to do is write out the entire equation with correct formulas, with correct formulas, with correct formulas. And I want to drive this home as much as I can. When you write your equation, right, you don't get to just arbitrarily change the subscript in the formula. You have to use the rules we learned last semester for writing correct formulas. Even if that means it's going to throw your equation out of balance. You write the correct formulas first, right? The correct formulas first. Okay. Then you're going to examine both sides to be sure that there is the same amount of everything. So let's take aluminum solid, right? And we're going to add that to a copper chloride solution. That's what the AQ means. All right. Now, if a reaction were to take place, the aluminum, which is a 3+, copper in this case is a 2+, chlorine is a 1-. Whoops, sorry about that. Okay, we would be able to predict, based on what we've already learned, that aluminum would combine with chlorine and copper would end up off by itself. That's a single replacement reaction. Okay? Now, notice that because aluminum is a 3 plus and chlorine is a 1 minus, I write AlCl3, right? That 3 needs to be a 3. It has to be a 3. Okay? Okay. So we do that. Now, what we should notice is after I've written my skeleton equation, so that's what this is. This is a skeleton equation that is not currently balanced. We've got 1 aluminum on this side. We've got 1 aluminum there. We've got 1 copper there. 1 copper there. That's good. 2 chlorines. 3 chlorines. Okay? Now do not just say, oh, I'm going to change that to a 2. Don't do that. Don't do that. Don't do that. You guys may have noticed that I keep saying this over and over again. That's because you silly chemistry kids want to try to do that. You can't do that. Leave the formula in its correct form. How, then, do I balance this? This is a problem. This is a problem. Okay? But it's a problem we fix with coefficients. We don't fix it by changing the subscript. Okay? So, this is out of balance. We got an unbalanced equation. We got too many chlorines on this side. We have to account for where that extra chlorine came from. So now, we're going to go back and add coefficients to fix that. Okay? So, here's what it would look like balanced. Right? So, I had 3 chlorines here and 2 there. Everything else was fine before that. Okay? So I have a 3 and a 2. So what I have to do is I have to turn those into the same number. So you're going to take a 3 and a 2, and you say, okay, what's the lowest common denominator for 3 and 2? That would be 6, right? So I'm going to make it so I have 6 chlorines on both sides. I'm going to start with my element that's out of balance, by the way, right? So I put this coefficient of 3 in front of my copper chloride. Now what that does is that applies to the entire compound. That means I have 3 copper chloride compounds. So rather than now just having 1 copper, I now have 3 coppers, right? As shown in the diagram here, right? I have 3 times 2, 6 chlorines. Okay? Now I'm going to do the same thing to this side, right? I need 6 chlorines over here. So I'm going to put a 2 as my coefficient because 2 times 3 makes 6. So there's my 6 chlorines. Okay? Now as a result of that, though, the 2 applies to the entire compound. That also gives me 2 aluminums. Alright? Now, I've balanced my chlorines out, but as a result, that threw my copper and aluminum off. But that's a simple fix. I got 3 coppers here. I'm going to now put 3 here. I've got 2 aluminums there. I'm going to now put a 2 there. So I got 2 aluminums, 2 aluminums. 3 coppers, 6 chlorine, 6 chlorine. We're balanced. Okay? Now, this, in my opinion, in the dorky chemistry teacher opinion, I think this is kind of fun. Okay? It's like a little number game, and you guys play Sudoku, right? It's what you're doing when you're balancing reactions. You go back and you write the correct skeleton equation first. If you don't write that correctly, you can't do anything else correctly, right? With correct formulas. Then you just start playing with numbers, some trial and error. So using a pencil, for example, where you can erase, might be a good idea. When I say might be, I mean it is a good idea to use pencil when you're doing this stuff. Okay? Sometimes they're really easy. Sometimes you spend 10 minutes on one trying to figure it out. And then you finally get it. You're like, oh, that was stupid. But that's the way it goes with this. Okay? So what you're going to need to be able to do, okay, write skeleton equations using the correct subscripts. Examine the equation to determine if it's balanced, right? So you're going to look at each individual element, right, and try to make sure that they come out to the same numbers on both sides. And then you're going to use coefficients to balance if necessary, right? And by the way, quick side note, sometimes you do some balancing and you get, let's say we get 4, 2, 2, 4, right? Could we reduce all those to 2, 1, 1, 2, right? Sometimes just in your trial and error, you get this result, in which case you might need to go back and fix things, okay? So we always want that lowest whole number ratio when possible. Whole ratio when possible, okay? Now, sometimes you can't go back and adjust just because of the way the subscripts are and stuff like that, but sometimes you do need to adjust to the lowest whole number ratio when possible, okay? So this is we're gonna get lots of practice with this, okay? But please do this for me. Do this part right here. Write the correct formulas. Don't mess with the subscripts. Please, please, please. You're gonna make your chemistry teacher cry, and you don't want to see me cry. Nobody wants to see that. All right, you guys, you got your work cut out for you, and we're going to keep adding to this, right? This is what you guys did probably once upon a time in your sophomore or freshman science classes. We'll be taking this a few steps farther, but we need to get this part down. We need to get it down and get it down good. All right, I will talk to you later. Peace.